Hi guys, again, thanks for watching and keeping up with all of these videos and lessons. I know it's a lot. I know you have a lot of other online things too. We are almost through all of the content that we're going to need for your AP exam. I'll touch more on that later, but we are about to wrap up Chapter 9. Chapter 10 is builds really right on top of Chapter 9. Sometimes teachers actually kind of teach them together as one unit. And so after we wrap up Chapter 10 in our textbook, we are completely done, all new content, and we can start strictly reviewing for the AP exam. So I just pulled this up because this is the note paper that I want you guys to print out if you have a printer. Obviously, you can see there's really not that much to it if you just want to take notes on a piece of paper. The only thing that you would be missing really is this example question that we will also go through together. So just for simplicity, I'm going to go through it on my PowerPoint to make it a little bit easier. So we're going to first start with just kind of connecting this to significance test for proportions. I have the same 4-step process. A lot of the 4 steps are exactly the same. We just have to tweak it a little bit because we're going to be working with means or mu or x bar instead of proportions, which was p and p hat. So I'm going to start with the state box first. So you can kind of start taking your notes in the top left corner here. Okay, make sure you're using mu and not p because we're talking about means. So we're going to be looking at the average of something, average cookie weight. The example we'll do later is average amount of hours slept per night from students at Franklin High School. So your null and your alternative hypotheses should look a lot like what they did in the last chapter, but this time we're going to have mu instead of p. So here's an example, random number 5, and you will define your parameter right after this every time you do one of these questions. So where mu is the true mean cookie weight for the Oreo cookies, whatever, just something in context. So again, that's it for the state category. You're just writing your hypotheses, stating your parameter of interest. Now we can move on to the plan, which is very similar to planning for proportions. The stuff that's different you saw in the confidence interval chapter. So let's bring that up here. First things first, make sure your sample was taken randomly. If not, we would have to start over because our result from our sample or our statistic would not be accurate. So does it state in the problem? Can you quote that? Great. 10% condition, all of you have had enough practice with that, same as before. Lastly is the shape. You're looking for the problem to say that it's a normal parent population, normal population. This is where the sample came from. Or that it passes the CLT. I'll remind you that's when n is greater than or equal to 30. And if both of those fail, you have this last ditch effort where you can look at a graph of the sample data to see if there's skew or outliers. So this would tell us that the sampling distribution is normal if sigma is known. But remember, why would they be paying us to do all of this? If we already knew what sigma was, then we would have all of our information. We would probably know mu. So it's more than likely sigma will be unknown. So what 3, the shape kind of condition, is going to tell us is that we have a T curve. So just be ready to say passes the CLT, therefore we have a T curve. Something along those lines. All right, so that's it for all of planning. Let's move on to do. For do, I could not fit it all in one slide. So just take that into consideration. You might want to write a little bit tiny here. There are 2 slides because we have a little bit to talk about here. So again, I would start by identifying your statistic. Last time we just started off identifying p hat because that's the result we got from our sample. Why did we see this result? Was it very unusual, so we're very surprised by it? Or is it not that unusual and we can make our determination based off of that? After that, let's go back and identify what the null was. So what we want the center of our sampling distribution to be, because keep in mind, we're always assuming that the null is true. So I use mu sub naught That's a number 0. You might see it on College Board or time to time. They might talk about it as mu sub naught. It's basically the value for the null hypothesis. Standard deviation, you should recognize this formula. You should recognize this notation. But, however, again, sigma is usually unknown, so instead of the standard deviation, we'll probably be using the standard error, which is S instead of sigma, and therefore we'll have the shape of a T-curve. So here's a cute little T-curve for you. Remember, it looks a lot like the normal curve. The difference was there was more height here in the tails and a lower peak. Okay, for the second part of do, we actually have to calculate our p-value. That's what we spent all of the last section kind of practicing. So, whoa, that's a lot. Sorry, let's go through this together. In this case, because we have a t-curve, we're going to be going to t-CDF. So if you want to pause the video right here, pick up your calculator. I can't bring up a calculator on this screen for you, I'm sorry, but if you can follow along the steps with my voice, just go back into second distribution. It's number 6 t-CDF. And you'll notice you have a lower bound, an upper bound, and a degree of freedom. Nowhere is there a spot to enter the mean, or whatever our null is, and that standard deviation that we calculated. So why did I have you calculate that? Well, t-CDF is built, it's just not built as nicely as normal CDF is. The calculator can't standardize it for you like it was doing in the normal curve. So I showed you a video, it was a Khan Academy video where we found the z-score, we calculated, they called it the test statistic, it was really just a z-score, and then you could use that z-score in normal CDF if you wanted, but we all know normal CDF better than that, and we know we can just punch in the mean and the standard deviation and it does all of that math for us. t-CDF does not do that for you. You must standardize it yourself. It's really easy. Here's our formula from chapter 2 of the school year. We're going to type in whatever x bar was, see how far away it is from the null, see how far away it is in standard deviations. So we will type in this value, it's a t-score really, into either the lower or the upper, and then just keep in mind that the degree of freedom is n-1. After that, you guys know the gist. It should look really familiar. You reject the null if it is unlikely, if your probability of this happening, if the null was true, is so small that it's lower than alpha, reject that null. I don't think the null is actually true. Look how low of a chance this has of occurring. If it's greater than or equal to alpha, we fail to reject. Same kind of synopsis as last chapter. So let's look at that example quickly together. And then you guys can check Schoology to practice a couple more on your own. And that almost sums up chapter 9 for us. Just a lot of practice with these significance tests is all we have left to do. Okay, so it's recommended that teenagers get 8 hours of sleep each night. You think seniors in your school sleep less than, all right, I think I'm going to tweak this a little bit. Well, I'll just let you know, I didn't pay attention to the fact it said seniors, so we're just going to have to assume that there's over 500 seniors at Franklin, which is fine. Okay, sorry. You take a random sample of 50 seniors at Franklin and find they sleep an average of 7.3 hours with a standard deviation of 2 hours. Run this test at the alpha is 0.05 significance level. So, null is that it's 8 hours. 7.3 seems like it's almost an entire hour less than that. But with a standard deviation of 2 hours, is that really enough to say seniors aren't getting enough sleep, that they aren't getting 8 hours of sleep? So I'm going to set up my null and my alternative. I am assuming that the mean is 8 hours, but I'm trying to figure out if maybe it's less than that. So I'm going to use a less than sign here, where mu is the true mean hours of sleep, I would say seniors, at FHS get each night, if you're following along. All right, on to the plan. We have to see if it's random. So take a random sample of 50 seniors. Yep, so I'm going to actually quote the problem before I give it a little check. Take a random sample of 50 seniors at Franklin. Random, check. All right, 10%. Ooh, this isn't going to be perfect because I was being lazy and didn't read the question carefully. We can assume there are over, so 50 times 10 would be 500. Just change this to seniors at FHS. Close enough. There probably are somewhere close to that, but we're going to do the problem regardless. 10% condition passes. We can assume independence. This is all things that you're going to be wanting to say on your AP exam. Remember, the AP exam is not going to have any multiple choice this year. You are going to have to just do a phenomenal job on the FRQs they give you. I'm guessing there's going to be 3 questions considering it's a 45-minute test. I don't know. They haven't actually published that. But at about 15 minutes per question, that kind of breaks down to 3. Hopefully I'll be able to give you guys more information on that, but they have not released it yet. So the last part, let's talk about the shape. This one's pretty easy. 50 is greater than 30. So the CLT is satisfied. But look at all of what I'm saying. Since sigma is unknown, the sampling distribution is going to be a T-curve. It's just not a normal curve. Okay, I'll go back if you guys need a second. Or you can pause the video and kind of follow along with me there. All right, so for do, we're going to have to get that test statistic, that T-score. Where does this fall compared to 8 hours? Is it significantly less than 8 hours? Is 7.3 significantly less than 8 hours that we can say we reject it all? All right, so I'm going to identify my X bar. That was 7.3. Let me remind you again, I've said it a million times, the mean was 8 hours. So how does that number compare? How does 7.3 compare to 8 hours? Standard error, take me a little bit of time to calculate. I used S, so it's standard error, not sigma. Got 0.283. And so when I calculate my T-score, I say, look, this is less than 8, so I should have a negative T-score. How much less than 8 in standard deviations is 2.47. So here's a little picture of that. Here's your T-curve. Here's negative 2.47. You can see it's less than the mean pretty significantly. So our p-value is going to be this little space right there. So we have to figure out what this area is. If it's very, very, very small, I'm going to say, oh, wow, that was super unlikely. I think that we should reject the null and that seniors aren't getting enough sleep. And if it's sort of likely, we are going to fail to reject. Our test just didn't have enough convincing evidence. I think that looks really small, personally. So let's see. So go ahead, follow along. T, C, D, F, same place as before. We're going to be figuring out this area on that tiny little tail bear. So if you go to second distribution down to number 6, keep it in as negative 1 E99, change your upper to negative 2.47. The degree of freedom is 50 minus 1 or 49. You should get 0.0085. It's pretty small, as I predicted. So all of this needs to be said. You cannot cut corners here at all because the p-value of 0.0085 is less than the alpha value of 0.05. We reject the null, period. We do have convincing evidence of the alternative. Remember, this must be in terms of the alternative. So evidence that the alternative is true. Average number of hours is actually less than 8 hours for those seniors. All right, sorry to rush you at the end here, but I do want to show you the shortest shortcut ever in the world. If you guys want to try going to, I've showed you this a little bit before, stat over to tests in your calculator. Scroll down to number 2, t-test. You'll see data, you'll see stats. I did not give you all of the data. I gave you the stats. I told you what X bar was, and I told you what the standard deviation was. So click on stats. Press enter. Okay, you should see a spot to change out mu naught or the mean. So that was 8. X bar was 7.3. S sub x was 2, so they can calculate that standard error for you. Change n to 50, less than, calculate. Same thing,